Hello and welcome back. Today we'll be doing question 7 from the 2012 MAT. So let's get started. Question 7. Amy and Brian play a game together as follows. They take it in turns to write down a number from the set 0, 1, 2, with Amy playing first. On each turn, except Amy's first turn, the player must not repeat the number just played by the previous player. In the first version of their game, Brian wins if, after he plays, the sum of all numbers played so far is a multiple of 3. For example, Brian will win after the sequence 2, 0, 1, 2, 1, 0, where we draw a box around each round because the sum of the numbers is 6. Amy wins if Brian has not won within 5 rounds. For example, Amy wins after the sequence 2, 0, 1, 2, 1, 2, 0, 2, 1, 2. Show that if Amy starts by playing either 1 or 2, then Brian can immediately win. Suppose instead Amy starts by playing 0. Show that Brian can always win within 2 rounds. They now decide to change the rules so that Brian wins if, after he plays, the sum of all the numbers played so far is 1 less than a multiple of 3. Again, Amy wins if Brian has not won within 5 rounds. It is still the case that a player must not repeat the number just played previously. Show that if Amy starts by playing either 0 or 2, then Brian can immediately win. Part 4. Suppose instead Amy starts by playing 1. Explain why it cannot benefit Brian to play 2, assuming Amy plays with the best strategy. Part 5. Suppose Amy then starts by playing 1, and Brian then plays 0. How should Amy play next? Part 6. Assuming both play with the best strategies, who will win the game? Explain your answer. Now, in this question, I will be using some modular arithmetic, so if you're not very familiar, please go and have a quick look at how to do this stuff before completing the question. So, pause the video to have a think, and once you're ready, restart to see if you were correct. So, let's get started. So, if Amy plays 1 or 2, then Brian can play 2 or 1 respectively and immediately win, as the sum is then 3. Now for part 2, if Amy plays 0, then we have 2 cases. In the first case, Brian plays 1, and then if Amy plays 0 again, then Brian can win with 2. If Amy plays 2, then Brian can win with 0. Now, if you're solving this problem in the exam, you can actually just stop here, because we've now proven that there is a way for Brian to ensure that he wins. However, here we've also got a second case where Brian plays 2. Now, in this case, if Amy plays 0 or 1, then Brian can win with 1 or 0 respectively, like in case 1. And here we've proven that Brian can not only secure a win in 2 rounds, but can play his first move randomly. Now, we'll move on to part 3. If Amy plays 0 or 2 under these new rules, then Brian can win with 2 or 0 respectively. Part 4. If Brian plays 2, then the total is 3, and as we essentially want the total to be 2 mod 3, the total is now 0 mod 3, meaning Brian has wasted a round. Thus, it cannot benefit him, and he should most certainly play 0. Now for part 5. The current total is 1, and Amy cannot play 0, and needs to avoid a total of 2 mod 3. Now, if Amy plays 1, then Brian plays 0 and wins, so Amy must play 2. This takes the total to 0 mod 3. Brian cannot play 2 to win, as Amy has just played a 2. Now, for part 6. The current sequence is 1, 0, 2. Brian should not play 0, as that puts the total to 0 mod 3, wasting time, so he should play a 1. The current sequence is now 1, 0, 2, 1, and the total is 1 mod 3. Now, if Amy plays 0, then Brian wins with 1, so Amy must play a 2. This takes the sequence to 1, 0, 2, 1, 2, and the total is 0 mod 3. Now Brian should not play 0, as that wastes time, so he should play a 1. However, This leads us into a recurring pattern where Brian cannot make Amy lose, meaning Brian loses no matter how many rounds the game continues on for, assuming perfect play from Amy, and therefore Amy would win this game. And that's our answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.